Welcome to your Chapter 6, Lesson 10 and 11 review. I'm just going to go through a problem on each the Lesson 10 homework number 2 and the Lesson 11 homework number 2, just to kind of get you ramped back into all of the solving graphically and solving algebraically that we have to remember. Okay? So, really, what I'm going to end up doing here is let's end up doing number, let me just take a peek. Let's end up doing number 2, I think. Maybe not. That one's a line and a circle. Oh, let's do a parabola and circle. Oh, let's do number 3. Let's do number 3 together. And again, we're just graphing these because this is lesson 10. So we're just going to graph this parabola and line. All right. Now, the reason I picked this parabola is because of the frowny face and the 1/4 in front of the x squared. I just want to show you how to make sure you enter that in your graphing calculator correctly so that we can get the table. And then we'll get our line in y equals mx plus b form, put the line on there, look at intersection points. This is a parabola and line. So this is actually going to have 1, 0, 1, or 2 intersection points. So let's see, this is a negative sloped line. Okay, so we're looking at a parabola, a very wide frowny face parabola, and a line that are going to intersect on the graph 0, 1, or 2 times. So we'll kind of take a peek at that. All right, again, just graphically. So we're just, convert this into y equals mx plus b form for your line. Subtract that x over, and we get 2y equals negative x plus 12, and then divide everything by 2. So you get a y equals negative 1/2 x plus 6. So your slope is negative 1/2, and your y-intercept is 0, 6. 1, 2, 3, 4, 5, 6. And down 1, right 2. So that's why I drew my sample line that way. Down 1, right 2. Down 1, right 2. I know you can't see my screen anymore. I'm covered a little. Down 1, right 2. And then head back, up 1, left 2, up 1, left 2. As long as one of your moves is in the negative direction, you have a negative sloped line. And of course, we connect a line with a straight edge. I'm going to wait to label my line. Until after I get my parabola on here. So with my parabola, I'm just going to use my graphing calculator to enter it. And again, I know it's a parabola because the highest present exponent is an x squared. That's not the thing I wanted to grab. This was. There we go. Okay, so let's press y equals. And our parabola is blue. We got blue, good. Okay, so negative, and then in parentheses, I'm going to put 1 divided by 4 because our fractions are division problems, just division problems. Then x squared, and now plus 4, and we'll press graph to see it. Whoa, wide. Nice wide parabola there. And let's look at some points. I'm just going to graph the integer points. I know there's going to be a lot of, there's a lot of these, other kinds of points. Let's just graph those integers. Let's look at, it looks like our turning point is 0, 4, because we're kind of coming up to that and then back down. Let's look at what we got on this side. I'm going to write negative 8, negative 12, and probably do, let's write that. I'm just going to write my integer points. Probably going to do a little estimate of where negative 8, negative 12 is on the bottom there. And then I've got negative 6, negative 5, negative 4, 0, negative 2, 3, 0, 4. That's what I said I think the vertex is, right? And then 2, 3. Yeah, that makes sense because now I'm heading back down the other direction. So since I'm only writing integer points down, I do have to arrow up and down my table a little bit more often. So 4, 0. Oh, so I see my roots are negative 4, 0, and 4, 0. Those are my roots. Axis of symmetry, x equals 0, so the y-axis. My vertex is a maximum point because I'm a frowny face. Not me personally, but the parabola is a frowny face. 6, negative 5, and 8, negative 12. Okay. So let's do that. 0, 4, 1, 2, 3, 4. Okay. Ooh, maybe these don't meet at all. That would be interesting. 0, 4, and then 2, 1, 2, 3. Oh my goodness. I don't know if these guys meet. And then negative 2 up to 3. Negative 2, 1, 2, 3. Okay, just making sure because I know it's really wide, so it's not my typical parabola. Negative 4, 0. Yeah, this is real wide. 1, 2, 3, 4, 0. So there's my roots. These aren't going to meet. Wow. Okay, let me back this up for you. So you can see what I've been doing. Negative 6, negative 5. So 4, 5, 6. 1, 2, 3, 4, 5. Yeah, wow. 6, 1, 2, 3, 4, 5. And then 8, 11, 12. Just so I can get real nice and wide here. And then this is 10, 11, 12. Helps to have a graph right underneath it. A grid is like legit right underneath this paper, so I can kind of see my grid points. Whoa. Why is this one? Oh, because that's at 7. Sorry. That's why. See, that's why I tell you not to estimate. Off the graph. No intersection point. Wow, that's not like me. I'm just going to verify that on my graphing calculator. And I'm going to press y equals, and I'm going to enter down in y2 my y equals a negative 1/2 x plus 6. So negative 1 divided by 2x plus 6. Let's just press graph to see. Same thing. Wow. No intersection points. So there you go. There you have it. Y equals. Kind of glad I did this one with you because a bunch of you would have done this on your own and been like, wait, I didn't get an intersection point. What did I do wrong? And the answer would be nothing. You did nothing wrong. All right. No intersection points there. Bummer. Okay. It happens. Let's try one where there is. How about I go back to number... No, how about I just do number 4 because I'm on the same page. Oh, some of you are real pissed because you know that meant I just didn't use purple because red and blue make purple and didn't get used. No intersection points. Ha ha ha. Well, this is a parabola, and this is a smiley face parabola and a circle. And this could have 0, 1, 2, 3, up to 4 potential intersection points here. Depending on where the parabola lies and where the circle lies. So this circle has a center of 0, 0 and a radius of 3, because the square root of 9 is plus and minus 3, but we know we're not going to have a minus 3, right, as our radius. So 0, 0, 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 left, 1, 2, 3 down. And I'm not messing with that stupid compass again, because my pencil needs help. Wish I had my other compass. That one is awesome. But no, gotta have that stupid compass here. And I can't find my awesome compass. I messed up a little bit there, so I'm just gonna... I probably should have sketched in pencil first, but c'est la vie for you French takers. That works. There's my circle. I'll wait and label the equation once I get the parabola equation. This parabola, this is going to be interesting. So this parabola here, let's type in. I'll get the circled in red down there in a sec, but this parabola, it looks like, is going to have imaginary roots because I think the lowest it goes is 3. Yeah. So that parabola goes down to the 0.03, and that's it. The other direction is all up. So there's not many points that are going to fit. In fact, why don't I just do -2 to +2? Well, I'll write the other ones, but I'm not going to sketch those 12s again because we saw that I just made a mistake there, and that's why I tell you not to do it. So why don't I actually listen to myself? That's where the highest point will be. And then -1, 1, 2, 3, 4. And there's my vertex and my 1 intersection point of this parabola and circle. That's it. But you get your purple, you people that clamor for it. There it is. 0, 3 is your intersection point. And then let's label y equals x squared plus 3 and x squared plus y squared equals 9. So there you go. You've just got 3 problems left to do on your own there. And these were just graphing, right? So just graphing, got to know what you have, line, absolute value, parabola, or circle. And you got to make sure you put lines in y equals mx plus b form, parabolas in standard form so that you can enter them in your graphing calculator, circles in center and radius form, right? So there we go. Give that a try. Finish that guy up. And then, of course, here I'm asking you specifically to do both things. I'm asking you to solve this graphically and algebraically because I want you to match back up. And so the things that I'm using, I know I have intersection points so that the algebra will work. Okay. I'm going to do one of them and I want you to do the other ones. And that one that I do is this one because it's hard. Okay. This is a difficult one. And the reason that I say that is because if you look at this, that's not a perfect square. So when I take its square root to get my radius, I am going to get a decimal. And so my estimate there is going to be a little bit different looking. Okay. So that's the reason I kind of want to, well, you know what? Since I'm asking you to do both on these, how about here we skip 3 and I'll do 2. Okay, one where we actually have some algebra and graph that are more visibly going to work. Okay, so I'll graph first because we've been practicing the graph. We've got a smiley face parabola and we've got a circle. And this circle is much nicer as far as center being 0, 0 and radius being 3, because the square root of 9 is plus and minus 3, of course, but we're not going to have negative. We just graphed this, didn't we? Didn't we just graph this? Count out 1, 2, 3, count up. So you guys don't do number 3. Don't worry about that now that I've just said, you know what, let's just look at one that's nice and easy since we want to kind of connect these things. And that's how your test looks. Your test asks you one system to solve algebraically and graphically so that way, you can use each other, the graph and the algebra, to check each other. And then let's get a table on this guy. All right, so y equals x squared minus 9. So I just really have to change the back here. Press graph to see it. Oh, way down. Okay. My vertex is 0, 9 though, so that's all right. but got a lot of points that can fit. So let's go from negative 4, 7 all the way down to 4, 7. So negative 4, 7. Yeah, I'm right. All the way down. Negative 3, 0. There's a root. Negative 2, negative 5, negative 1, negative 8, and 0, negative 9. Yeah, that makes sense because that's my vertex and turning point, right? Or vertex is turning point. That's my axis of symmetry and turning point. So then 1, negative 8, and I'm coming back around 2, negative 5, and then I'm coming back around, and that makes sense for my other root. And then 4, 7. Yep. Okay. All right. So let's take a peek here. 0, negative 9. So I know I'm here. And then negative 1, negative 8, and 1, negative 8. And then negative 2, negative 5. So 7, 6, 5. And then all the way. Oh, my roots are also intersection points with my circle. Okay, let's see. Then I'm up negative 4, 7, 1, 2, 3, 4, 5, 6, 7, and positive 4, 7. Okay, so let's look at our intersection. I wonder if there's another tangent there. Algebraically, we'll find that. Because doesn't it look like there could be another point right here somewhere? This could be one of our 4s. This could exactly touch in only these spots, or this could be another tangent point. So I do at least know my roots are also intersection points right now. So I'm going to label them, circle and label those as 3, 0 and negative 3, 0. And I'm thinking potentially there's more, but let's take care of that. Let's just write this stuff first. And then let's take care of that algebraically. And if that is true, then we'll come back and label those up here. Okay, so definitely 2 points, possibly 4. Let's depend it on the algebra, which I gave you plenty of space, right? Gave you plenty of space for the algebra. And the whole point of the algebra part is, look, this guy right here, y equals this, right? So sub that in for y here. Okay, so your circle is x squared plus y squared. But if we know this, y is equal to x squared minus 9, then sub that in here and then finish up. So really, we're asking you to square this binomial. So let's do that. Let's bring that down and do x squared minus 9 times x squared minus 9. So we'll FOIL this. We get x to the 4th, and then minus 9x squared minus 9x squared. So what's that? Negative 18x squareds, right? Because we FOIL. And then plus 81 at the end, right? So that's when I've squared those. And then bring down the other stuff. So now let's combine like terms as much as we possibly can and move this 9 over here. So subtract 9. I really didn't need the parentheses around that, sorry. Subtract 9 from both sides and combine this and this. So I get, what's 81 minus 9? 72. Or I could have done that in my head because I'm not a moron. Let's see. Sorry, I didn't mean to call anyone who didn't do that in their head a moron. That was not my intention at all. That was more making fun of myself because, hey, you're a math teacher and you could do that basic subtraction. You know. Anyway, well, this is about to tell me that there are 4 intersection points. My gut was right. This is factorable. That's a factorable trinomial, okay? So I'm going to get rid of the graph for a second, but I'm going to factor this trinomial. And this trinomial factors to become, the other ones are not rational numbers, just so you know. This factors to become x squared minus 8 and x squared minus 9. Yup, there it is. this is, of course, dots, so that will factor further. Bring down the x squared minus 8, and then we've got x minus 3 and x plus 3 equals 0. And now just t-chart these three equations, okay? So these two are the easy ones because they're linear equations. So you get x equals 3 and x equals negative 3. Okay, so really with these two, if you plug them back into your parabola, right? 3 squared is 9, 9 minus 9 is 0. So I get a matching y of 0. So that intersection point, and I'll do it in purple for you haters there, is 3, 0. And then I do that again over here, and I get y equals 0 again. So your intersection point, you purples, are negative 3, 0, right? And those we know, we already knew those because those were the obvious ones on our graph. Here is where the challenge comes into play. X squared minus 8 equals 0. Well, you have to add 8 to both sides. So you get x squared equals 8. And then to get x alone, you take the square root of both sides. Well, we did these, we solved these back in chapter 6. This is still chapter 6. But chapter 6, lesson 2 was taking square roots of both sides, right? So this is plus and minus, and reduce this radical. Square root of 4 is 2, 2 radical 2, which means that I've got an x value of 2 radical 2, and I've got an x value of negative 2 radical 2 that I have to plug into my y equals, one of my y equals, and find, or excuse me, one of my two equations and find the matching x. I would pick the parabola. And the reason I say I'd pick the parabola is it's just a little bit easier to plug in for y. So I get y equals, and then it's this squared minus 9. Okay, and we'll see what we get as a matching y. That's going to be our intersection point. So it's 2 radical 2. I just want to show you real quick. Second and quit. 2. Oh, let's do it in parentheses. 2 radical 2. Exit out and square it. It's 8. So I get a y value. Oh, 8 minus 9 is negative 1. Excuse me, I didn't finish. Oh, let's just finish. Minus 9 equals negative 1. So that means that the intersection point here is 2 radical 2, negative 1. And I'll show you how I can kind of see that. Negative 1. Yeah, that makes sense. I'll show you that, how I can kind of see that on my graph. And then, of course, I do that again by plugging in. And the thing here with negative radical 2, when I square it, it's the same. It'll give me 8 minus 9. And I'll just prove that real quick to you using your graphing calculator. And arrow over here. And I just want to make this negative for you. Second and insert. I insert a little negative, and I do that. And so I just want to prove to you that that will still give me a positive 8. And the 8 minus 9 is still negative 1. So what this means is on the other side of my circle, there's another match. Okay? So there are 4 intersection points. There are 4 intersection points. And when we graphed this, I said, oh man, it looks like there may be 2 more intersection points that we can't currently see. So let me just head up here and show you negative 2 radical 2 and positive 2 radical 2 on my graphing calculator. 2 radical 2 is 2.8-ish, right? So 2.8-ish. Negative 2.8 is over here, and down to negative 1, right about there. That's negative 2 radical 2, negative 1. There's an intersection point. And here we go, 2. I'm just trying to really make it obvious. Positive 2 radical 2, negative 1 as an intersection point right there. There's our 4 intersection points. Now, would you have known about those radicals As far as this, if you didn't do this algebraically, absolutely not. By the way, is one like this on your test? Absolutely not. Much easier than this on your test. Okay. Much easier, much more straightforward. But you can see how the graph can be deceiving if you don't do the algebra, because I don't know for a fact about any of those other tangents if I'm not checking using that algebra. Okay. So this really was important to know how to do this step to make sure you have all the intersection points. The other ones I gave you in lesson 10, by the way, those were the straightforward intersection points. We're not missing anything by not doing the algebra. So that's the reason I kind of gave you the problems that I did there versus here. Well, anyway, I want you to practice these. Don't do number 3. So I did say don't do number 3. If you want to see the answer key to it, I did post it, but don't worry about you doing number 3. If you just do 1 and 2, well, I did 2, but if you just do 1 on chapter 6, lesson 11, homework number 2, that's plenty as far as the algebra goes and in getting you ready for the test. Trust me on that. This other one is a real good one getting you ready for the test. Pretty sure that's the one I used on the test, but you'll find out very soon, right? Okay, guys, let me know if you need any help with these. I did post the answer keys, so you have them, but just in case, you know, practice the graphing of those pieces, practice the algebra of those pieces as the check for your graph, and look for those intersection points, because this is putting it all together. This was the whole point of doing all the good stuff that we did with parabolas in chapter 6. So good luck. I'll see you soon. Bye, guys.